file, it will be open in Google Colab environment. So here I am in my Google Colab environment. Okay. Now for this project one, I have to import some important Python libraries. So these libraries are three. So I have to import tree from Scikit-learn, and then from Scikit-learn.tree, I will import decision tree classifier. I also need matplotlib, and also from Scikit-learn.tree, I will import plot tree. So these are the important file or libraries which I need for this project. Let's run this cell to import these important Python libraries. Now it's time to generate the data. So I am going to generate a data having 4 columns. So I will use 3 columns as a feature, and the 4th column will be the labels of the dataset. If we see here, I am going to use pd.dataframe. So I am going to use pandas data frame in order to generate my data. So the columns are age, experience, health condition, and selected. So the age, experience, and health condition will be used as a feature, and selected is used as a label. If you see, it has 2 entries, that is no or yes, that is whether the candidate is selected or it is not selected. Okay. Now let's run this cell in order to generate our data in the form of data frames. So we can see that from 0 to 12, we have 13 samples in the dataset. We have age, experience, and health condition. If you see health condition, its maximum value is 9, and its minimum value is 4. Basically, this is the health condition score between 1 and 10, and these are the values. So 9 means, in this data set, 9 means the health condition is good, and 4 means the health condition is worst. Okay, so this is experience in years, and this is age. So this is our data set. So if we see our labels, they are in the form of strings, that is no and yes. So we have to transform them into the number so that we can feed them into our computers. So here we are transforming labels of the dataset into integers. So how we are transforming? I will replace yes by 1 and no by 0. Here I am creating a dictionary. Yes and no are the keys, and 1 and 0 are the values. And here I am replacing my column selected with this dictionary. So I am mapping. If you see the function .map.d, here I am mapping this dictionary to my column selected. So if I run this set, so after mapping, I have replaced no with 0 and yes with 1. Now this data set is ready, and now I can use my decision tree classifier in order to perform the classification. So it is the time to extract features and labels. So the features are age, experience, and health condition. Okay, and labels are only the column which is selected. Let's run this cell to extract features and label. Let's see the features, and we can see that we have 3 values in our feature matrix, that is age, experience, and health condition. Let's see our labels. So we have 2 unique values in our label, that is 0 and 1. Okay, so the features have been extracted, labels have been extracted. Now it's time to instantiate our decision tree classifier to perform the classification. So here I am instantiating my decision tree classifier, and I am calling it as a decision tree D tree. Okay, run this cell. So we have instantiated our decision tree classifier. If you see here, I did not pass any input parameter. There will definitely be the input parameters which could be passed here. Let's see the document of a decision classifier. We have learned that whenever we learn about a new classifier or a new function or a new module in a Python, it is always a good practice to see the document of that module. Okay, so pass decision tree classifier in the help function to see the document. So here I have opened the document of a decision tree classifier. If I scroll up and see the function decision tree classifier, so we can see that here is a decision tree classifier. So for a decision tree classifier, the most important input parameter is a criteria. So the criteria they are using by default is a Gini criteria. We have learned in this section that there are 2 possible criteria in order to find the value of the information gain and to construct the decision tree. One is entropy and other is Gini impurity. So here the criteria which is being used as a default is the Gini impurity. So what we are going to do, first we will construct a tree with the default value, that is with the Gini impurity. Okay, so we have already instantiated our classifier. Now it's time to train the classifier. So here I am training my classifier on the data. Let's run this cell. And now it's time to visualize the tree. For tree visualization, I am going to use a function plot underscore tree. The first input is decision tree classifier. Field is equals to true. And the feature names will be taken from the feature matrix. That is, the columns of a feature matrix are the feature name for this decision tree. Let's run this cell. Okay, so this is our decision tree. If you see this decision tree, let's open it in a new window. So if we see here a decision tree, we can see that it starts from the health condition. It means the health condition is the most important feature. Next, if we see the Gini value, so the Gini value of the health condition is 0.497. It has 13 samples, out of which 6 belongs to class 0 and 7 belongs to class 1. So this is the Gini value of the health condition. Now, what is this 6.5? So this 6.5 is the value of the health condition from which the split starts. Okay, if we go back and see the column health condition, so this is our health condition. It has value 9, 4, 6, 8, 5, and 7. So the split start from the health condition value of 6.5. So if you remember the second lecture of this section, where we learn how decision tree works, we have selected two features, x1 and x2, and based on x1 and x2, we learn how to split the tree. So if you remember that lecture, the first split start from the value of x1 less than 50. So this is the same concept. Here, the split start from the health condition value of less than 6.5. So this is the value of health condition from which the split start. This is the Gini value of the health condition. These are the sample present, 6 belongs to class 0 and 1 belongs to class 1. Now we split this decision tree, or we split this root node in order to construct the decision tree. Here is the first branch and here is the second branch. So here we can see that all the 5 samples have been classified as 0. So all 5 samples belongs to class 0. Here the classification has been finalized. Therefore, for this leaf node or a terminal node, the Gini value is 0. So this becomes our terminal node because this node does not need any further split. Now here we can see that the Gini value is 0.29. We have 8 samples, 1 belongs to class 0 and 7 belongs to class 1. Now we need further split. If we do split here, now we can see that all the 4 samples in that part of the split belongs to class 1. Since the classification has been finalized, therefore the Gini value is 0. Now here we are left with 4 samples. Out of them, 1 belongs to class 0 and 3 belongs to class 1. So we need further split of this branch. When we split it further, we get 2 samples here and all these belongs to class 1. It means the classification has been finalized. Here the Gini value is 0.5 because 2 samples, 1 belongs to class 0 and 1 belongs to class 1. So we need to split this branch further. And here the classification has been finalized. The sample belongs to class 1. Therefore, the Gini value is 0. And here the classification has also been finalized. The sample belongs to class 1. Therefore, the Gini value is 0. So we started to construct our decision tree from the important feature health condition. And we reach up to the terminal node or leaf node where all the Gini values are 0. So we started from the highest Gini value and we reach to the lowest Gini values. Okay, let's see which feature is important. From the tree, we have already seen that health condition is important. Let's calculate the important feature or find the important feature. So this is the important code. Here we can see that the decision tree dot feature underscore importance will give us the value of each feature. Let's run this cell. So here we have generated using pd.dataframe. The index are our columns of the feature. So we have three features: age, experience, and health condition. So these feature becomes the index of this data frame. And these are the information gain values. So if we see the information gain of health condition is 0.76, which is the highest value. That's why tree start from the health condition. Okay. So we have understood about the tree. We have understood about the information gain values. Now it's time to test the tree to get the predictions. Since we have already used all the data set during the training, so here we have to generate a testing sample. Here I am generating my first testing sample. In my first testing sample, the age is 40, the experience is 11, and health condition is 6. Let's run this cell to generate first test sample. So this is my first test sample. Let's pass this test sample to my decision tree classifier to get the prediction about the class of this test sample. Let's run this cell. So according to my decision tree, it belongs to 0. That is, the candidate is not selected. Let's generate another testing sample. So in this testing sample, the age is 70, experience is 21, and health condition is 9. Let's pass this testing sample to my decision tree classifier and get the prediction about the label. So here we can see that the prediction is 0. So the prediction is 0. It means the candidate is not selected here. Okay. Now it's time to create another decision tree, and this time I am going to use the criteria entropy. We know that the default criteria is Gini, but we can also pass the criteria is equals to entropy when we instantiate our decision tree classifier. So here I am instantiating my decision tree classifier. The criteria is entropy, and after the instantiating, I am training this new decision tree classifier on my training data. Let's run this cell. Let's see the tree again. So this time again, the tree start from the health condition, but this time the entropy values are given. If you see everywhere, the entropy values are given. And here again, we can see that the split start from the value less equal to 6.5 for this health condition. So this is the same tree which we have obtained using the criteria Gini, but this time our criteria is entropy. Okay, let's see the most important feature. So we can see that again, the most important feature is the health condition. And we can see the information gain value is 0.66. So this is the information gain which is obtained using entropy. Now, since we have already generated 2 test samples, let's get the prediction label from this decision tree. Okay, we have to change the decision tree here. Here it is written as decision tree, but now we have called it as a entropy underscore tree. So I have to replace it with the entropy underscore tree. Let's run this cell. And I also have to replace it with entropy underscore tree. Okay, let's run this cell. So we can see that for test sample 2, it is predicting as a class 1. And for test sample 1, it is predicting as a class 0. So in this project, we have learned how to implement decision tree classifier in Python using both the criteria, that is the entropy and the Gini impurity. So I hope you understood this lecture. I hope you understood this project. I hope you understood this implementation. Thanks for listening, and I will see you in the next lecture.